Hi students, in this video we are covering the triangle inequality theorems. So our objectives are to learn both triangle inequality theorems, and we're going to apply the theorems in the context of real world applications. All right, so first, if we have a triangle, we're going to call this triangle ABC, then the side opposite the smallest angle is the shortest side. So we have three angles, 89, 54, and 37. 37 is the smallest angle, so side BC is the shortest side. And then for 2, we have the side opposite the largest angle is the longest side. So 89 degrees is the largest angle. So side AC is the longest side. And then the other value is just the middle value. And so we'll just say side AB is the middle length. So that makes sense. The biggest angle should open to the widest angle should open to the longest side. The narrowest angle should open to the shortest side. So then if we have three side lengths that are given, then the angle opposite the longest side is the largest or the widest angle. So angle, let's see, we have side PQ. So side PQ corresponds to angle R. So R is the largest angle. And then the angle opposite the shortest side is the smallest angle. So we have 8, which is side QR. That goes to angle P. And so angle P is the smallest angle. And that's going to mean that Q is the middle value. So for this section, we're going to get back into naming sides of triangles using 2 letters. So if I give you a side, so if a triangle is named with 3 letters, in this example, we have triangle XYZ, and it has 3 sides, XY, YZ, and XZ. Given the side that has the 2 letters, it's opposite. The angle that is opposite that side is the missing letter of the triangle. So remember, our triangle is XYZ, so we have side XY. The letter that's missing is Z. That's the opposite angle. So we have YZ. This letter that's missing is X. That's its opposite angle. And then we have side XZ. The letter that's missing is Y. So Y is the opposite angle. So that's how we name sides in a triangle. We're using 2 letters. The letter that is missing is the angle that is opposite that side. So for example 1, we need to order the sides of the triangle from shortest to longest. I'll let you take that one. Pause it, come back and see what you get. All right, so if we're looking at our triangle, so angle E is the smallest angle. So if you want to first put the angles in order from smallest to largest. So for angles, we have angle E, then we have angle G, and then we have angle F. Then for sides, remember, it's just the other 2 letters that make the sides. So that's going to give us side GF, side EF, and side EG if we're going from least to greatest. So the answer to this is GF, EF, and then EG from shortest to longest down. So for example 2, we're doing the same thing. We have to order the sides of the triangle from shortest to longest. This time our triangle is triangle DEC. So first we need to find angle E. So the measure of angle E is equal to 180 minus 56 minus 29, which is 180 minus 85. So that means that angle E is 95 degrees. So 95 degrees. So now if you want to write the angles in order from shortest to so our angles from most narrow to widest, we're going to start with angle C, then we have angle D, and then we have angle E. And so then our sides, if we order those, so across from angle C is side DE. So we have side DE. And then across from angle D, we have side CE. And across from angle E, we have side, why did I write an angle? We have side CD. So from angle C, if you draw an arrow, just going to the opposite side. That's how you know the opposite side. Just draw an arrow from that angle. Or again, it's just the other two letters. So then for example 3, we have to order the angles of the triangle from smallest to largest. And if we write our sides in order, so if we write our sides in order, we have WY, then we have WX, and then we have YX. And then for our angles, then remember the triangle is triangle WXY. So the letter that's missing is the angle. So we have angle X, angle Y, and then angle W from smallest to largest. So then in this example, we're just given the sides of a triangle. So let's change QR. We're going to change that from 5. We're going to change that to 4. Then let's see. So if we have to put the sides in order, so we order our sides first, then we have QS, QR, and RS. And then if we put our angles in order based upon our sides being in order, we're going to have angle R, angle S, and angle Q. Because again, remember, the angle that is opposite a side is the missing letter in the triangle. All right, so then we have the actual triangle inequality. So 3 lengths of a triangle can form a triangle if and only if the sum of the 2 smallest sides is greater than the largest side. So in this example, you see this GIF of, we're going to say a triangle has 3 sides. So side A is 3, side B is 5, and side C equals 8. The reason that the other 2 sides have to be more than the third side is that if they equal that side, you can just fold them down onto the largest side and they perfectly make that length. So again, you can see that the side that is 3 and 5, they exactly meet to make a length that's 8. And so if one of those sides is a value that gives you something more than 8, then the diagram can't collapse altogether, and we'll get a triangle instead of just a line on top of another line. So it's very important that you understand that given 3 side lengths, they can form a triangle if and only if the sum of the 2 smaller values is larger than the largest value. And they can't equal, they have to strictly be larger. So for example 5, we are determining if the sets of numbers can form a triangle. Pause the video and come back. All right, so for this first set, we have 8, 9, and 12. Can we form a triangle? The answer is yes, because 8 plus 9 is more than 12. For the second example, we're going to have no, and that's because 7 plus 13 equals 20, which is not, and that's not greater than 20. So that would be just like in this example where in the place of 3, 5, and 8, we could say that size 7, this size 13, and this size 20. Well, you're just taking a 7-inch side, for instance, and a 13-inch side and collapsing them on a 20-inch side, so they're going to meet perfectly. So that doesn't work. For the third set, we have we're going to get yes, and that's going to be because 2 plus 2 is greater than 3. For the next example, we're going to get no, and that's going to be because 4 plus 6 is less than 11. So you remember the 3 sides have to be more than the third side. So 4 plus 6 is not more than 11. And the last one is, what if you just had 3 unknown sides based upon some side x? What we know to be true is that x plus 1, that has to be greater than the largest side, which is x plus 2. So 2x plus 1 needs to be greater than x plus 2. If we subtract x, we're going to get x plus 1 is greater than 2. If we subtract 1, we're going to get that you can have a triangle given x plus 1, and x plus 2 as long as x is greater than 1. So if you use 2, 3, 4, 1.1, for instance, all of those values will work. All right, so that's the triangle inequality. So now let's put this in practice in some real world examples. Oh, I'm sorry. We got one more thing. So we have to find the missing range for possible values for a third side of a triangle. So if you know 5 and 11 are 2 sides of a triangle, what's the possible value of a third side? So say we call this, so the 5 is side 1, 11 side 2. Is it possible that side 3 equals, we'll say 4 inches? Could side 3 equal 4? All right, so if you said no, you said no because if the third side was 4, then 4 plus 5, that's less than 11. And remember, the triangle inequality says the 2 smallest sides have to be more than the third side. So now what if you choose, so that's one thing. What if side 3 was equal to 13? Is that possible? Well, let's see. Then if we have a triangle that has 5, 11, and 13, then that's going to imply that 5 plus 11, which is 16, is greater than 13. So the answer here is yes, we could make a triangle. But what if, so right now we had no, we had yes. What if side 3 equaled 30? Then you have a triangle, a possible triangle where you have 5, 11, and 30. So then 5 plus 11, which is 16, that's less than 30. So the answer here is no. So like, what's the range of values that we can use to make a triangle? Well, the way this is if A and B are known side lengths and X is the missing side, then X is between the difference of the 2 side lengths and the sum of the 2 side lengths. So in the previous slide, we'll say that A was equal to 11. Oh, actually, I wrote that. I'm sorry. Let me get my eraser out. So if we have A is 11 and B is 5, like we did on the previous slide, then 11 minus 5 is 6, and 11 plus 5 is 16. So in that example from the previous slide, we had 6 is less than X is less than 16, which means that our third side has to be something between 6 and 16, because the third side can't exceed the sum of the 2 if 5 and 11 are the two smallest sides, then x can't be more than their sum. But if 11 is the largest side, then it can't be larger than 5 plus the other value. So that gives us the 11 minus 5 part. So for example, 6, a triangle has side lengths AB is 6, BC is 15. What are the range of possible values for AB? I'm sorry, that should be AC. That should be AC. Excuse me. That should be AC. So the maximum value that could happen is AC is the large. So if AC is the largest side, then that means that AB and BC are the two shorter sides. And so AC can't be more than their sum. So the maximum is 6 plus 15, which is 21. Now, the other thing that could happen is that one of the given sides is the largest. So that in this case, that would mean that BC is the largest. So then if BC is the largest, it can't be more than AC plus AB. So that means that the minimum value that AC has to be is 15 minus 6, which equals 9. So that means that the range of possible values for AC is from 9 to 21. AC can be any value between 9 and 21. Example 7, we have to circle the values in the table that could be a missing side in triangle XYZ. So all we need to do is come up with our boundaries. So the maximum value is going to be 7 plus 4, which is 11. And the minimum value is 7 minus 4, which equals 3. So the side that we're missing is YZ. So YZ has to be between 11 and 3. So we just want to circle all of the values strictly between 3 and 11. So that's going to mean we get 5, 4, 6, and 8. And we exclude 1, 12, 2, 13, 3, and 11. So there are 4 possible side lengths there. And again, decimals are included. You could have 5.5 or 4.5, but we're just going on integers because that makes this easier to understand. So example 8 is a standardized test question. So Pine Street, Rector Street, and Taylor Street intersect to form a triangular shaped park. And we want to know which is the correct order of the lengths of the streets from longest to shortest. So first, all right, so pause the video and see if you can come up with the answer. All right, so if you're joining me back, first you should find the missing angle. 64 plus 54 is 118. So 64 and 54 is 118 degrees. So that means that, I'm sorry, that's 118, and then 180 minus 118 degrees is 62 degrees. So the missing angle is 62 degrees. So if we put our angles in order, we have 54 degrees, 62 degrees, and 64 degrees. So the street that's opposite the 54 degree angle is Taylor Street. So we're going to have Taylor Street. The street that's opposite the 62 degree angle is Pine Street, which forces Rector Street to be the last one. So we want Taylor, Pine, and Rector, which is going to make D the correct answer. So again, we found the missing angle, and then we ordered our angles from least to greatest. And based on that, we ordered our sides from least to greatest. And the last one is the diagram shows the locations of Noah and Ben after swimming in different locations from a dock. D is the distance from Noah to Ben. What are the possible values in yards of D? So they form a triangle. So so D could be the maximum. So if D is the maximum, the largest side, then 84 plus 63 has to be more than D. So we're going to get the maximum value is 84 plus 63, which is 147. The other thing that could happen is that 84 is the largest side. And so that means that the other two sides have to be more than 84, or 84 minus 63 is the minimum value, which is 21. So D has to be between 21 and 147. All right, so that concludes our video on the triangle inequality. A quick review of what we covered. First, given three angles in a triangle, the longest side is opposite the widest angle. The shortest side is opposite the most narrow angle. Given three side lengths, the widest angle is across from the longest side. The most narrow angle is across from the shortest side. And then we had the actual triangle inequality, which says that three lengths can form a triangle if and only if the sum of the two smallest sides is greater than the largest side. And to find the missing side given two side lengths, you add them to get the maximum, you subtract them to get the minimum, and those are your boundaries. All right, thanks for watching, guys.